Hi everyone, and welcome to our first video for topic 9. This is a video where we're going to be reviewing a little bit of stuff we kind of did in a limbo, right? Where we talked about parallel lines and transversals and the angle relationships of parallel lines and transversals. So let's break that down. For people who might not remember too much about parallel lines or need a little bit of a refresher, right? Let's look at that. Parallel lines are lines which never meet. They never intersect. There's other ways to see them though, right? That's one way to define it, but another way is lines that never get closer and they never get farther. They're always the same distance apart. If they're getting closer, they would intersect. And if they're getting farther than they were getting closer, if I was to like rewind the tape or whatever, and I could see, rewinding the video, they're getting closer and they would eventually have started together at some point. So whether they're getting closer or farther, they would be intersecting, right? So the only way to never intersect is to be the same distance away. Likewise, if I was, some person standing here, hello, right? Then I can see, to me, the angles at which I'm looking at them are exactly the same to me, right? This angle and this angle would be exactly the same. So they're also kind of traveling in the same direction, right? Because remember, when we're just talking about, you know, no distances here, the only thing to really measure is direction. And parallel lines go the same direction because if they were going different directions, they'd cross over each other's paths, right? That is an important connection between parallel lines, that they travel the same direction. So remember that. Now, notationally, I don't want you to have to look at the picture and guess if two things are parallel. We're going to notate that by putting these double arrows, which indicate they're parallel to each other, right? If I wanted to have multiple sets of parallel lines, I would use different numbers of arrows. So like one arrow or three arrows, right? That's how I'd say, some lines are parallel if they're connected by three, some by two. Same way as we do the tick marks for congruency, right? Now, we also would write this in a mathematical sentence as m is parallel to n with a symbol standing for the is parallel to part, right? When we're doing proofs in a bit or other statements, we don't want to have to write out all these words. We want to be able to make it pretty quick, right? So that's why we use that is parallel to notation. Okay, now what is a transversal? We talked about that at the start. Now, when we're talking about parallel lines, we said there are connections between them, right? That they're traveling the same kind of direction. A transversal is a good way to see that direction. A transversal is a line that intersects two or more lines in a plane. So it's kind of like what connects the two parallel lines, right? Imagine that these are, train tracks and this is the crossing going over the train tracks. Now, it does not need to be an intersection of parallel lines specifically, just any two lines. But most often you're going to investigate transversals when it comes to parallel lines because interesting relationships are made, right? So looking at the angles that are formed here, these 8 angles, you can probably immediately start seeing a connection between the angles, maybe even more than one kind of connection, right? You see angles that look similar to each other and the angles that seem to be the same measurement, right? So maybe pause the video and look at the angles and kind of think about that. What do you notice about these angles and their connections? All right, maybe you paused it for a minute or two. Welcome back. Hopefully you at least consider that, what connections you see in the angles, because that's what we're going to be talking about this video, right? So as we investigate this, I encourage you to think about that, and I also especially encourage you to think about how would you tell me what angles you're seeing connections between, right? Would you say the angles on the outside of what? The angles on the top of what, right? So now you might be saying, if I'm trying to describe this, right, or if I'm trying to tell you what angle to look at of those 8 angles, I need a good way to refer to the specific angles I'm talking about, right? And that's exactly what we're going to add real quick. When we're talking about where to look to see angles, we use the transversal and the parallel lines as a reference, okay? So first of all, I can tell you to look inside the parallel lines or outside the parallel lines. Imagine these are train tracks, like we said earlier, right? The interior is where the train goes, and the exterior is where the people loading onto the train go, right? Or imagine that these parallel lines are hot dog buns. The interior is where you put the hot dog. The exterior is where you try not to put the condiments, right? Because you want them to land on the hot dog. You probably don't want anything from the hot dog ending up on the outside of the hot dog buns, right? So that's a good way to see interior, exterior, fancy words for inside parallel lines, outside parallel lines, right? Remember, these lines go on forever. So this is really like, you could see it as being inside a fence, like an exhibit. Okay, now this is just one way to refer to them because again, if I was to use just this way of noting it, right? Interior covers 4 possible angles. So I haven't really narrowed it down too much, okay? So the next thing I'm going to use to connect angles is the transversal. We can talk about the sides of the transversal, right? There's a left side and a right side in this case. We don't really care about left versus right. What we care about is if the angles are on alternate sides of the transversal. In other words, they're not on the same side of the transversal, right? One's on the left, one's on the right in this case. Or if they're on the same side of the transversal. In this case, both being on the right side, right? If they're on the same side of the transversal, we call it same side. And if they're on opposite sides of transversal, we call it alternate. Notice when we say side, right, we're not talking about the parallel lines. We're not doing interior exterior. We're specifically referring to the transversal. So with these notations, we're now going to be able to explore the relationships and connections you might have seen between these angles. So check that. What we'd call the parallel line postulates, okay? Remember, postulates are things we can assume to be true. We looked at this and we went, that's true, right? Parallel lines are kind of interesting in that a lot of what we work with parallel lines is an assumption. We don't prove much about parallel lines. They're an assumption we make in the initial rules of geometry. And in fact, some forms of geometry don't make this assumption. They don't assume that parallel lines never intersect. They don't work with parallel lines very much. Or if they do work with parallel lines, they assume they can intersect. Interesting, right? So all the things we're talking about now only work when we do assume they intersect, which means they in themselves are assumptions. The first one is corresponding angles, okay? Corresponding. What does corresponding mean? We'll investigate that more in a future video, but for now, think about this. The angles that look alike, because it kind of just seems like they're the same relative position, right? These parallel lines look a lot like copies of each other. They look congruent to each other, right? They're not congruent because lines don't have a size, right? But they are in the sense of being parallels of each other, you know? It means that, again, when they meet this transversal, they meet at the same angle, right? The same angle is how they meet. So because they meet the same angle, these two angles are corresponding, right? They're both the angle that is on the upper left of where it meets, and they're congruent to each other. Likewise, I can highlight this angle and see those are congruent to each other. And likewise, these are congruent to each other, and these are congruent to each other. Those are what we call the corresponding angles. Upper left, upper right, lower right. They're the same relative position, but in different vertices. Remember that for corresponding, because again, when we go into it more in the next video, or in a future video rather, you might really want to remember this as a good example. All right. So that is what most people see when they look at these angles. If you did take that time early in the video to examine that, right? That's the one that jumps out to people. Remember, postulates are often self-evident, right? Things that kind of just seem to be true. But there's some other connections that seem to be true. One of them is alternate exterior angle. So remember, alternate is on opposite sides and exterior is on the outside. So those two angles are equal to each other in their measure, so they're congruent angles. Likewise, these two angles are equal angle measures and congruent angles. Now, we can kind of just know that, right? Because if you think about it, we already were able to establish that, this blue angle in the upper left is congruent to this corresponding angle. And so this angle is the vertical angle of that lower left one, right? So by vertical angles and corresponding angles, we can prove that alternate exterior angles are a thing, right? So we only need to assume corresponding angles. But even without those, you can just look at this and kind of just tell, right? That not only does it seem like my parallel line was just translated down, it also kind of looks like it was rotated 180 degrees down there, right? And remember, we'll review this in the next video as well, but rigid transformations produce congruent things, right? So rotation, translation, all those are going to be congruent. All right, next one. Alternate interior angles. So same basic idea, same logic, right? These two angles are congruent. How do I know that? Well, I also know that this angle right here is the same as this angle. And again, by vertical angles, right, I can show that. So those are all congruent to each other. Same basic logic, just now it's on the inside instead of the outside, right? All right. The last one's a little different, consecutive angles. These are also known as same side interior. I like to remember this one by thinking of a horseshoe, okay? So I'm looking inside this U shape, and I'm going to be checking these two angles against each other. And these are not congruent, they're supplementary, right? And let's think about why. We've already established that this angle right here corresponds to this angle. And this is a linear pair, if you remember our angle relationships, right? This is a linear pair. So I know that this green angle, right, up here is going to be corresponding to this green angle down here, and it's supplementary to that lower angle in the consecutive angles, right? I'm going to use some different colors to make that even clearer, because those are not congruent like before, right? They are supplementary to each other. So for example, if I was to do this, right, I could say that this one was 100 degrees, which would make this one 80 degrees. If you look at it, you can immediately tell they're not congruent, right? Because looking at it, this one's very clearly acute and this one's very clearly obtuse, right? So they can't be congruent because one of them is obviously less than 90 degrees. So that's a good way to double check your work and make sure you're not accidentally doing a congruency relationship when this is really a supplementary relationship. So those are the four postulates for parallel lines with a transversal, okay, what we call the parallel line postulates. Three of them are congruency relationships, and one of them, consecutive angles, is supplementary. Why the exception? Well, consecutive angles are really useful in the real world. Very often you're going to be working with two parallel walls, some other wall coming across, and you need to configure these two angles to match to make that happen. That's a supplementary relationship, consecutive angles, right? It's just a very quick way to remember this stuff. There's even more relationships than these four, but they're all kind of just built from these. So really, those are less common. These are the most common relationships we see.